In October 2017, astronomers using the panstarrs telescope in Hawaii detected something strange. A faint dot of light, moving too fast to be bound by the sun's gravity. It wasn't from our solar system. It was from somewhere else, another star system, perhaps hundreds of millions of light years away. They named it Oumuamua, which in Hawaiian means scout, or messenger from afar arriving first. For the first time in human history, we had detected an object that originated outside our solar system. But as scientists scrambled to observe it before it disappeared, they realized something unsettling. Oumuamua didn't behave like anything they had ever seen. It wasn't a comet. It wasn't an asteroid. In fact, nearly a decade later, we still don't know what it was. Today, we're going to explore the mystery of Oumuamua, its bizarre shape, its unexplained acceleration, and the theories that range from the mundane to the extraordinary. This is a story about how the universe surprised us and how one tiny object forced us to question our assumptions. A race against time. When Oumuamua was first spotted, astronomers immediately knew it was unusual. Its trajectory was hyperbolic, meaning it was moving so fast that the sun's gravity couldn't capture it. It had come from the direction of the constellation Lyra and was already on its way out. They had only a few weeks to observe it before it faded from view. Initial observations revealed that Oumuamua was dark, reddish in color, and roughly 100 to 400 meters in length. But its brightness was strange. It would get brighter, then dimmer, then brighter again by a factor of 10. This suggested that Oumuamua was elongated, extremely elongated. The most likely shape was a cigar-like object, perhaps 10 times longer than it was wide. No known asteroid or comet in our solar system has such an extreme shape. As the data poured in, the mystery deepened. Oumuamua didn't have a coma, the fuzzy cloud of gas and dust that surrounds a comet when it heats up. But it also wasn't behaving like a solid rock. Something was off. A push with no explanation. Here's where things got truly strange. As Oumuamua sped away from the sun, it should have been slowing down. Gravity is a predictable force, but when astronomers tracked its trajectory, they found that Oumuamua was accelerating, gently, but definitely accelerating. It was being pushed away from the sun faster than gravity alone could explain. For a comet, this behavior is normal. As a comet approaches the sun, its ices vaporize, releasing gas and dust. That outgassing acts like a rocket engine, giving the comet a tiny push. But Oumuamua showed no signs of outgassing. There was no visible coma, no trail of dust. Yet, it was accelerating. Scientists considered other possibilities. Perhaps it was made of hydrogen ice, which would vaporize without leaving visible debris. Or perhaps it was nitrogen ice, like the surface of Pluto. But even then, the acceleration didn't quite match the models. Something was pushing Oumuamua, and no one could agree on what. A cosmic pancake? For years, the leading theory was that Oumuamua was a cigar-shaped object tumbling through space. But in 2021, a new analysis suggested something even stranger. The way Oumuamua reflected light could also be explained by a different shape, a flat, pancake-like disk, thinner than anything we've ever observed in space. Imagine a disk the size of a football field, but only a millimeter thick. That's the kind of shape that would produce the same brightness variations. If that's true, Oumuamua was not a rock or a comet fragment. It was something entirely different. Perhaps a shard of a larger body, torn apart by tidal forces near a star. But here's the problem. We don't have any natural objects in our solar system with that shape. We don't even know if such a shape is physically possible for an object traveling through interstellar space. The shape alone is a mystery that challenges our understanding of planetary formation. A reasonable controversy. This is where the story took a dramatic turn. In 2018, Harvard astronomer Avi Loeb published a paper suggesting that Oumuamua might be artificial, a piece of alien technology, perhaps a light sail or a defunct probe. He pointed to the acceleration, the strange shape, and the lack of outgassing as evidence that this was not a natural object. The idea ignited a firestorm. Many scientists dismissed it as sensationalism. But Loeb's argument was not unscientific. He argued that we should consider all possibilities and that the simplest explanation for an object that accelerates without visible outgassing is that it's being pushed by radiation pressure, like a solar sail. And a solar sail would be thin, flat, and artificial. Most astronomers remain skeptical. They argue that outgassing from hydrogen ice or nitrogen ice could explain the acceleration without invoking aliens. But the debate highlights a fundamental truth. We don't have enough data to rule out either possibility. Oumuamua was detected too late and observed for too short a time to get definitive answers. A natural explanation? One of the most promising natural explanations came in 2020. Researchers proposed that Oumuamua might be made of solid hydrogen, a substance that has never been observed naturally in space. Hydrogen ice is so volatile that it would vaporize at extremely low temperatures, far from the sun. If Oumuamua were a chunk of hydrogen ice, its surface would sublimate as it approached the sun, giving it a gentle push without creating a visible coma. The problem is that hydrogen ice has never been observed in an interstellar object. It might exist in the cores of giant molecular clouds, but we've never seen it. And the theory requires Oumuamua to have formed in a very specific environment, a cold, dense cloud, and then survived a journey across interstellar space. Other scientists proposed nitrogen ice, like the surface of Pluto. That would also sublimate without a visible coma. But again, the models don't perfectly match the acceleration data. The truth is, we may never know exactly what Oumuamua was made of. A new class of object. Regardless of what Oumuamua was, its discovery changed astronomy. Before 2017, we had never detected an interstellar object passing through our solar system. Now we know they exist. And we know they're common? Since Oumuamua, we've detected a second interstellar object, 2I/Borisov, which was clearly a comet. Borisov behaved exactly as expected, with a beautiful coma and a tail. So Oumuamua is not alone, but it's unique. Borisov was normal. Oumuamua was strange. This suggests that there is a whole population of interstellar objects out there, and some of them are very different from anything we have in our own solar system. We've only just begun to study them. The Vera Rubin Observatory, scheduled to come online soon, is expected to detect dozens or even hundreds of interstellar objects in the coming years. Each one will give us more data. And eventually, we may find another Oumuamua. And this time, we'll be ready. The missed opportunity. The greatest tragedy of Oumuamua is that we didn't see it coming. By the time we realized it was there, it was already on its way out. We had no spacecraft ready to intercept it. No mission could be launched in time. All we have are a few weeks of telescopic observations, faint, blurry, and incomplete. If an interstellar object like Oumuamua were detected today, we might be able to launch a mission to intercept it. Proposals exist for fast response spacecraft that could rendezvous with future visitors. The European Space Agency and NASA have both studied concepts for intercept missions, but they require funding, planning, and most importantly, early detection. What could we have learned if we had gotten a closer look at Oumuamua? We could have imaged its surface, analyzed its composition, and definitively answered whether it was natural or artificial. we could have understood its shape, its structure, and its origin. Instead, Oumuamua remains a blurry dot in the data, a mystery that will likely never be solved. The messenger from afar. Oumuamua came and went. It's now far beyond the orbit of Neptune, heading out of the solar system forever. In a few thousand years, it will cross the Oort cloud and continue its journey through the galaxy. We will never see it again. But its legacy is profound. It reminded us that we live in a dynamic universe where objects from other stars pass through our neighborhood unnoticed until we learn to look. It challenged our assumptions about what is natural and what is possible, and it sparked a debate that continues to this day. Was Oumuamua a rock, a chunk of ice, a relic of a dead star system, or something else entirely? We may never know, but the next time we detect one of these messengers from afar, we'll be ready. And that's the real gift Oumuamua gave us, a wake-up call. What do you think Oumuamua was, natural or artificial? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.